We are asked to prove by induction that n cubed plus 11n is divisible by 3, where n is a positive integer. In induction, I'm not going to teach induction in this video, I'm just going to run through the problem. But it is important to remember that in induction, when you're proving by induction, you always need to check first that the proposition is true for n equals 1. And as such, we can start by saying let n be 1. And let's see if that's true. When we put 1 in here, we get 1 cubed plus 11 times 1, which is 12. Now 12 can also be rewritten as 3 times 4. And this means that yes, when n is 1, the result is divisible by 3, because we have 3 times something. And this something is really not that important in this problem. Moving on, we assume that the proposition is true for n equals k. I just like to use the letter k. And as such, we say, okay, let's assume that then k cubed plus 11k is going to be 3 times something. Let's call the something m. I also like to use the word m. I don't know why. That's how I was taught. And so we assume that this is true. Now we're going to prove that it is true using k plus 1 to equal n. Now, where does that get us if we let n be k plus 1? Let's expand. It will get us here. K plus 1 cubed plus 11k. Now, what is this? When you expand this... Oh, sorry, I meant 11k plus 1. I forgot the 1. When you expand this, you get k cubed plus 3k squared plus 3k plus 1, right? This is just binomial distribution. You can watch my binomial distribution video if you don't know what I have just done here. Plus 11k plus 1. Now furthermore, and cleaning this up, we'll give k cubed plus 11k plus, look, something nice will emerge. 3k squared plus 3k plus 12, right? I have added 11. Oh my goodness, did I forget a 1 here again? I have added 11 to 1, which gives 12, and then 11 goes here, 3 goes here. This here is very convenient because it is essentially 3 times k squared plus k plus 4. Now where does that get us? If we always remember have to use this, what's up here upstairs. We always use, because in induction you have n, you let n be k and assume the statement is true, the proposition is true, and then you prove it using n is equal to k plus 1. And so we go back to what n is equal to k, what this assumption gave us, and we notice that this is the same as this. And so we can rewrite this as 3m plus 3k squared plus 3k plus 12. Isn't this lovely? I think it is, because what this gives us is 3 times m plus k squared plus k plus 4. And this essentially is the same as this. We had to prove that this is divisible by 3. And when n is equal to k plus 1, which is just any integer anywhere out there, positive integer, it has to be, remember, it will give us 3 times something. Now we don't care what the something is, as long as we can factor a 3 out of it, which tells us that it is divisible. Don't forget the last step in induction is always a reasoning step, and that would be, in this case, you have to write that true for n equals 1. So the assumption, the proposition is true for n equals 1, as well as n equals k and n equals k plus 1. And then the last step, this is just what I like to write, a very formal one. Hence, the proposition is true for all, and now you always have to look back to what we were given, for all, oh this was bad, for all positive integers, for all n belongs to positive integers. And now we have proven it by induction. You can use this method whenever you're asked to prove divisibility in induction. You always try to factor what you're trying to divide by.